Thanks for joining us. This talk will be done by myself, but with a very important guest. I want to introduce you Antoine, who is the CTO of Google Europe, and so he's a big boss there, and he
Just
wants
Google Cloud, but
Google Cloud, but it's okay. It's just in a few years away. Uh, so Antoine, maybe you can present yourself even better.
Sure. So Antoine Larmanjat, hi everyone. I work for Google Cloud. I've been working for them for like 2.5 years. We have, I belong to, as you can read there, I belong to a team called the Office of the CTO, which basically is the CTO, a team of CTOs across the world. And what we do is that we look at Horizon 2, Horizon 3 topics. So what is going to happen in the world of software, hardware, cloud? Not now, but in like 2 years, 3 years, 5 years from now. So we're kind of halfway between research and implementation. But we don't do research and we don't do implementation. So we kind of build kind of early products for our customers, and we do what we call customer-driven innovation. So customer-driven innovation is basically the ability to kind of understand what the customers need, but also understand what's coming up in technology, and then try to see what kind of new products that could mean for cloud.
Okay, so today it will be kind of a mixed presentation because we are going to talk about mainly the total cost of ownership, what actually costs compared to a classical project, a no-code one, with some real examples. But we also will stop with Antoine on some specific topics to try to dig a little bit more about where no-code should be used or not, and what would be the future of these tools. So first, before anything, that's the moment to not forget them. They're still fighting. Please help them anyways. So myself, I'm a developer, coded a lot of stuff, so I love coding, 3D engines, telcos, switches, whatever. I was running a digital agency with 400 people, so only doing tech, ERPs, e-commerce, and now I want to do less code, so that's why we founded Code.Store, which does pretty much the same, building projects using no-code and low-code systems. So maybe the first point is, Antoine, maybe it's interesting to ask yourself, what from your perspective is a no-code, low-code platforms? Can you define no-code? What is no-code for you?
Well, there's plenty of definitions. If you just, what are the motivations for companies? So before I worked with Google, I worked with several companies, and I was in the financial services for Euler Hermes, a subsidiary of Allianz. I was with ING. I started also a payments company. And for all of the companies that I worked with, the major problem and the major motivation that we had was, there's a talent shortage. It's super hard to find developers and great developers. It's difficult to keep them. It's difficult to hold them. It's difficult to pay them. It's difficult to motivate them. So there's never enough developers for what you want to do. And my experience as a CIO in my previous jobs was, if you want to keep up with the demand from your customers, no code or low code is a great opportunity, because you cannot provide the amount of output with regular code that you can provide with regular code. So give you an example. I don't know if you have people from my previous company, but we were able to kind of output a few applications a year before we started using no-code, low-code. Once we've embarked in kind of democratizing this to what we call citizen developers, or what you guys call citizen developers, we were able to kind of rapidly increase the pace of applications. So basically, it's a productivity thing. The more you use no code, the more you should be able to increase your productivity from an IT perspective.
Okay. So, and I would define it from a more technical point of view. So for us, the no code and low code is a natural kind of last step, last increment from the classical. We started with chips and wires, and when we did assembler, I did assembler myself, move AX, BX, so working very closely to the CPUs. And then nobody did that anymore. We started to using compiled languages and then interpreted languages. And finally, once we have the right powerful browsers like Chrome, we had script languages and finally frameworks on top of them. And now, for me, it's the last step is the low code and no code, when you actually can avoid writing code. It's funny to see, because we just had a discussion just before when Antoine said, yes, well, that's the one point. And another thing we have to keep in mind is actually AI writing code, right? What's you doing on Google? Because this is a big competition of actually, without doing with all these tools, it actually just write in plain English what you want, and the program will be created.
Yeah, so one of the questions that we are asking ourselves right now is, I don't know, you guys probably heard a few years back, there was a big revolution that took place in AI called the transformers. Transformers, large language models, these types of things are able to ingest a huge amount of data, put that in a very big large language model, AI model, and was able to, and we were able to kind of predict and translate and really interact with machines very efficiently. So that, for example, because it could take context into account much better than what we were able to do before with, neural networks like recurrent ones and stuff like that. So with this new technology, that you can apply it to code, and we've started we've seen some startups doing this. We've seen people doing that. We are also working on these things. And basically, if you apply large language models to code, you can think a little bit about of this, like, what are the two ends of the large language models? It could be natural language on the one side and code on the other side as the output, or it can be vice versa, or it can be code from one language to another. So you can imagine a huge amount of possibilities there. Like you can go from English to Python, but you can go from Python 2 to Python 3. You can go from Python to English. Python to English is nice because you write your Python code and you click something, and then you get some kind of comments and documentation and things like this.
Okay. That's very interesting, because this is something that you usually don't see here, because there's a lot of tools, but there are also another things that's coming away from coming.
Can we just stay on this slide? I have one little comment, because we don't talk a lot about this. I don't disagree with that. It's great. But there's one thing we need to be not very careful, but very aware of. It's sustainability. We don't talk. I don't know if sustainability was a topic that was discussed during the summit, but the lower you go, the more efficient you are from a CPU cycles perspective. The higher you go, the more inefficient you're going to be. So Python is something like, I don't know, an order of magnitude less efficient than C++ from a number of cycles, efficiency. This will create more energy consumption, more sustainability constraints. So if you're a small company that doesn't really care, that might be fine. If you're a huge company that doesn't like their electricity bills, or if they're on-prem, or they're afraid of this, so the ability to write code that is efficient, that doesn't do too many cycles is super important. So that's going to be a challenge for the no-code, low-code industry, is to keep sustainable stuff.
Yeah, I think that there will be drive based on if the energy bills start raising up, there will be a kind of automatic market pressure that we will probably do things. So another thing we can ask ourselves, why did it took so long? Because when you see modern 2002, like Retool, App Store, App Farm, App Software, whatever, and when you look Visual Basic in 92, it looks pretty much the same. But actually what we needed before getting to the no-code, what we was needed a lot of things. We needed APIs because it's quite complicated, because I think that we'll talk about that, but the no-code works really well in the front-end part, but not in the back-end part. We need powerful browsers, because without that, how could we execute all these apps and front-end stuff? We need frameworks, because you cannot do the complex UI elements and the complex interfaces without having the frameworks like React. And finally, we needed usage, because like 10, 20 years ago, the industry needed much more like financial reporting, e-commerce, CRM. And now, once those are solved, because we have many vendors, we need way more applications, thousands of them, small applications to optimize some processes, or BPM, or maybe some commercial activities. And finally, we need also UX stability, because while we were experimenting what works or not, now we are not anymore. So now we can actually reuse things. So basically, about this last point, why the UX stability? Why all the cars look the same? Look at that. They all different vendors, but they all look the same. It's not because they are very not creative. It's because they actually optimize to what the customers want. So at the end of the journey, this is what we as users of cars want. So, and the websites follow pretty much the same structure. If you see this, for example, you will see that all the websites look almost the same, selling very different things, but you cannot spot the difference. This is exactly why the sign-in and sign-up forms are always on the right part of the screen. That's because the users, it's most optimum solution, and also because users can get used to that. So basically, that's exactly what we have for Nocode. We started that the push for more complex front ends came in like 2010s, and we see the both from Google and from Facebook, React and Angular, which actually then pushed to the headless architecture when we separated the front end and the back end in two different groups. So we had specialists in the front end and the specialist APIs in the back end. And finally, we have this Mac Alliance or Mac architecture where we are relying on microservices, API first, cloud native, and headless, which is very popular. Most of the applications have been built today are relying on this architecture. And finally, now it's time to have the no-code, I think. So as I said, from my perspective, there is a domain where the code is predominant, business logic, databases, microservices, critical business application. And there a domain where I think no-code will dominate within a few years is everything that more relied on the front end, internal apps, mobile apps, website, or portals. What do you think, Antoine? Because we've discussed a little bit last time about that.
What do I think of all this?
Well, just about.
All right, no. So I can talk from a little bit of experience. What made low-code, no-code applications successful was when they didn't have to reinvent the business logic, when they were able to interact with the back end of the company. The business logic, the security was already there, the business logic was already there, the APIs were already there. And then it's not just front end, but it's more front end plus orchestration. So it's an essential part of the microservices that you want to do. I wouldn't say that it's limited to just front end, but it's front end using the security, using the API. So basically, if you can kind of segregate or separate your APIs, and by the way, APIs are not just REST. They can be gRPC, they can be streaming, they can be bidirectional, they can be plenty of things. And they will be, because the needs are increasing. So if you separate your business logic and you keep the governance of the business logic within IT or within those who know how to manage the security, manage the business logic, when there's kind of a true strong governance around it, then you can free up the rest to the rest of the organizations, and that's what creates productivity.
So yeah, well, that's I just to put in perspective. Like if you are like an IT director, you probably recognize this scheme, which is a domain-driven hexagon. Like all big applications, more or less, follow these principles. And the sweet spot for Nocode for me right now is exactly what you say, is orchestration and usage of everything that is being controlled by the IT with security, with entities and business domains here. So that kind of the ideal architecture that might arise if you can recognize many of the patterns. We have big ERP systems like CRM or ERP. We have PIM, Product Information Management, Order Management System that communicates with databases. We have these microservices. But at the end of the journey, we might have this API gateway at some point that protects the backend systems, and then we have different kind of use cases: mobile apps, internal apps, or HR portals. So the green ones are the ones which are good for no-code. So now now we got this kind of long introduction about no-code. Let's dig a little bit about how the money is spent on a classical project, because before comparing the total cost of ownership of a no-code platform, let's see how on the classical project the money is being spent. So first, very important, when you do code, you produce bugs, and then they have to support them the entire life. So a classical project, you will have different phases. You have the design phase, the organization. I would not say phase because it's a more waterfall, but more, let's say, activities. You have the design activities, the organizational activities, and the build themselves. And within each of them, some of them can be replaced or changed dramatically with no-code and low-code. So a lot of things happening here in the build. You have to work with API connection. You have to construct your system with data structures. You have to do your front-end UI element placement and control those components. And you have to CRUD on databases and writing logic and a lot of things. So when you just finish building your software, it's not finished yet, because then you have this run, the hosting cost, obviously, and you have to organize your application, how you will deploy it, how you will run it, with containers or not. Do you need API gateway, storage, CDNs? And then you will also have to work with the maintenance of your code, and this is extremely important. When I was running ADX, we used to have this ratio: 50% to build, 50% to run until decommission or replatforming. That means that half of the money will be spent on the build and half of the money will be spent on the run. I don't know if you did similar things in...
Yes. It is working? Okay, good. So just one thing that we didn't mention, but I think it could be interesting to discuss also, is between the world of containers, servers, cloud, and the no-code platform. You still have like the business logic and everything. And there's another realm that is not just becoming, but is also very, very important. It's serverless. So serverless, we didn't talk a lot about it, but it's also a game-changing thing. So serverless at the big... And serverless sometimes is difficult to explain or difficult to get accepted by IT teams, because IT teams, they like to do their little containers, they like to deploy their little containers, they like to manage, they like to care about their scalability and everything. So there is sometimes some resistance in the beginning to serverless, but it's also it's kind of the step zero of no code. So it's still code, but you have zero infrastructure to take care of. At Google Cloud, we have put a lot of emphasis on serverless, whether it's with databases like BigQuery and others. We all the cloud functions, Cloud Run, the ability to run your containers and everything. So I think an intermediate step between traditional IT and no code is serverless, and it's also an interesting kind of first step to kind of free yourself from managing machines, managing servers, and it's usually a lot cheaper because you don't use the resources that you don't
So maybe
you don't pay the resources you don't use.
Even sustainable in a way, because you don't run in a machine without having actually the
Even what?
sustainable. I mean, from if you just
Sustainability, yeah, absolutely.
So the problem is that when this is how you do what money being spent on a project, but then let's dig into what a developer actually does every day. So this is a real survey and a real data with some numbers. So when you think of a developer making a lot of code, that's not true. The developer codes a little bit more than 30% of his time. The rest is being spent on sending funny memes to Slack channels. But the code maintenance, for example, is an important thing. The more code you write, these numbers can change, and at the end you can end up like 80% of your time refactor and maintenance. Testing, for example, meetings just to agree with each other team members how to write code, what kind of code have to be written, security issues, documentation, deployments, all this in training, because every day there is a new framework, new tooling to be used. And this is just for the development part. If you take the management track, you have a lot of meetings again, backlog requirements, what have to be done, testing the software, and finally, in the DevOps, they write Terraform or procedure to CI/CD the components and deploy them in production. So actually building software today, it's not really about reading code. That's a problem for no code, because actually the code itself, it's not a real problem. But everything else takes a lot of time.
Yeah, and just to complement what you said, when you're a large corporate and you have repos that are like millions and millions of code, it's super difficult to maintain. How do you maintain a repo that has, millions of files, millions of code, without spending more time to understand what's in there rather than writing new stuff? So that's a big challenge. Personally, I think that AI will play a big role there. So AI will allow customers and corporate enterprises to understand what's in their code, to kind of refactor the code, to reorganize the code, to identify areas where you can build an API here because you see that there is interaction. You will be able to kind of compare the logs in real time of how your code runs with the code itself and see how you can adapt it. And that would be also one kind of step towards no code in the future. But still, maintenance of large repos of code is one of the biggest headaches that large corporates have.
Interesting, because if we, so this is exactly what just we saw, but then because when you put these numbers of time spent with money, this is what you get, because skilled professionals, the really good ones like Node.js senior developer, React.js senior developer, Python developers, they cost a lot. And this is low numbers. This is really low numbers. You can go way higher, but in France it's 600 a day, US 800, Ukraine 350, India. But at the end, if you put that in terms of sprints, for example, so we take a small agile team, 5 packs, so it's classical agile team. Well, that's 30,000 a sprint. So there's a lot to do all that. It just spent on maintenance, and only 30% of that is about building new features, right? So, and that's why, for example, if you take in perspective, this is what actually been raised by those startups, and we can imagine that most of this money went to building software and not to marketing, because it's a pre-seed founding. So it's a lot of money being spent just to build a Uber app or Instagram app at the very beginning, before all the scalability issues, before everything we know today. So this is the very first rounds. So now let's see how it happens in the no-code projects. So, well, the first thing, what you actually do not have to do. So let's compare something like building internal application with React, and let's say you're using Retool. So what will happen when you want to build an internal app, for example, with React and let's say Node.js? You will have UX guys designing in Figma, and then UI guy will be designing in Figma, and then you will have to transform everything that is in Figma. Now Figma is for Adobe, so in front end. So you basically just to create the HTML and the CSS and the JavaScript things and the grids and stuff. And then you have to write your data binding, so how these components that are very static will actually interact with internal model. And then the control, what happens if I click on the button. And then you connect that to the API and deploy the code finally. So if we take the same example with, for example, a tool like Retool, but it works with AppSmith, it works with App Farm software, whatever, you can replace it. You basically have the UX guy, because we still think it's important to have a UX guy, who building the interface, and then you only have the development activities actually to connect these different components to an API and writing the workflow rules. And you don't have deployment and stuff, okay? So does it make the 2 times faster? Even more, we'll see why. So because, as I said, the maintenance of the code is where the money is being really spent. So building something very quickly, we might say, okay, code, no code doesn't really make a difference. But when you start to modify, refactor, change, adding new features on a large code base, this is where it really complicated. Just not adding a new button, because you actually, when you just add new buttons in code, you might result in many different buttons, colors, shapes, and way to do things. And this will result in a lot of time spent to just understand what we already have. And if I didn't found what we already have, I can create a new button, so a new piece of code that have to be maintained and that enlarges the code base. And this is normal. Like, look at these iterations. Okay, we have kind of fruits, and then we need maybe slightly different. It didn't really work with users, so we change again to make it with radio buttons, and change again to the almost optimum result. So this is how the iteration could work. And each time you do that in a code, you create code, and that potentially may stay in your code base because it was forgotten, nobody touches it, we commented it, so it's added, it can add bugs. So actually, there is a way to solve that issue in large companies. It's what we call design system or reusable components, and it's something that Material UI, for example, for Google, is for. You can't create software with reusable components, so to avoid that. But the initial cost is extremely important at the beginning, and usually you don't have the founding because the project is still in the beginning, so you don't do that. So you start doing custom components, you start to write custom code, and then the costs of maintaining raise exponentially. You could start, if you are founded enough, by doing your reusable components, but again, the costs at the beginning are quite important. And the idea, and the most importantly, before being reusable, the code have to be first usable. So you are not sure what have to be reused, what should be actually part of the design system. So that's why when you are working, again, on the front-end part with no code, you actually get access to tested, verified across hundreds of thousands of usages, reusable components that you can actually plug and use. And then the cost, depending on the number of interface elements, will be non-exponential but linear.
Yes.
So wow, I get the yes from Google. So this is actually the scalable products. You have to inverse the pyramid. When you have these building blocks, this is what you had, the custom elements and the majority of the application. Then you have some composites, and then you have building blocks. But in no code, it's the reverse. You have the building blocks, the composite, and only at the end you have these custom elements.
Yeah, and the challenge is to not get frustrated if you're not able to do the custom elements, because what we very often say about no code, oh, it's great, but whenever it's going to become complicated, I'm not going to be able to do it. If you manage to kind of segregate your business logic nicely, then the the cost of custom elements shouldn't be too high.
So let's take a real example. So so this is an example of an app for managing breakfast. You know, you arrive in a hotel, and they said, "What is your room number?" And then they cross your name in these 4 or 5 pages of paper. That's exactly what we are building now for Accor. So I'm very transparent. This was the first proposal we sent them, saying, look, guys, we're going to make a very classical, very small app, React backend, connect to your ERP, getting the guests list from them, and then building the app with React. So we said, okay, the budget is between something like 15 and 19K, very small budget, just for a first iteration MVP. And then we said, but look, there is another option. If you agree using no-code tools, which will have some constraints in terms of customization, in terms of UI elements, you agree, this will be the next cost. So this is a real example. So obviously they took the second option, and we divided almost by three times cheaper, and still making margin. So this is just MVP. Then deployment, obviously, over all hotels is more complicated. So the app looks like that. So this is what the guys from the hotel Pullman here are using. You arrive, they select the guests. They say how many arrived, if it's the breakfast is included or not. That's it. So it was something that was pulled out in a few weeks, and now it's being tested on one hotel and before deploying to 4,000 hotels. And the funny thing is that there is no complexity of deploying that going from 1 to 4,000, except for the part about the training, change management, and going in each hotel explain how it works. But technically speaking, the deployment itself, the scaling is almost automatic.
And maybe one challenge will be that, because I've seen that also, is you have a no-code or low-code application that functions, that works well, that people are quite happy with. And then there's the question that comes up that says, shouldn't we redo it in the normal way? Shouldn't just we refactor it without no-code so that it becomes a professional application? And the challenge for the no-code platforms will be, no, there's no need for it. The challenge will be that, no, we have enough features, we have enough capabilities, we have enough that you don't need to refactor it, that you can stay. So that's it's all the better for everyone, because one, you are able to spend less to create your application, and second, you don't have to redo it once it's in production.
So then you might say, but what about the cost of the platform itself? Because you still have to run the application stuff. For the SMBs, the prices are ridiculously low. If you are not a big company, this is just an example of some of the tools. But even if you take very big companies like OutSystems and Mendix, which are really more enterprise-oriented, even then the price tag is quite acceptable, specifically if you compare it with the cost of a developer. 2 or 3 days of a developer equivalent 1 month of licensing. So if the economy of scale is here, and okay, if you go to enterprise, the prices will be quite high. You should go something like about 100, 200K per year for big enterprise subscription models for this. But still, 100K is just one full-time developer. So.
Yeah, maybe one challenge is in the way we manage the kind of the economics of programming and IT. There's a kind of a general feeling sometimes that, you know, when CFOs take too much importance in the way that they manage IT budgets, they think that building software is like building a house. So 99% of the cost is in building the house, and then maybe every 5 years you're gonna repaint the walls, maybe change a few tiles on the roof and stuff like this, but it's gonna be minimal. But that's not the case. In fact, the cost or the overall cost is going to be like reinvesting 30% of your cost of software every 5 years, every 3 years. This change of accounting technique for CFOs that are used to CAPEX, a lot of CAPEX, and then when the CAPEX runs out, you should not spend anything on the application. I mean, that's old thinking, but it's still very, very relevant in many corporates, and that's an issue. So one challenge for the no-code platforms will be, okay, we're going to go from a CapEx world where you develop and then you don't spend anything to more of an OpEx world where you need to constantly pay a little bit, a lot less, but a little bit to maintain and to keep up with the security, the new features, the new stuff on a continuous basis.
But I think it's a good thing for CFO too, because CapEx is very complicated for a financial point of view. Okay, because you have this on how many years this immobilization will work, and it's not easy to calculate the life cycle, the lifespan of a software. It might be 1 year, it might be 10 years, and the decision is made mostly by CFO who have no idea and who are not users. So OpEx is obviously an easier and more agile way of piloting the cost of the IT cost, because then you can, if you're decreasing the activity and decreasing number of users, then it's easy to actually decrease the spendings and then increase them when you have more activity, for example. That's pretty it. So if you guys have any question, so yeah.
Yeah, one moment.
Here in the middle.
Thank you. I don't know if it's working. Yes. You were mentioning change management as an agency. How are you dealing with that with the customer? Are you handling it within your team, or?
It depends. Obviously, in a very large corporation, we are not able to do that. But we usually, the usual pattern is have these super users or ambassadors who will be trained extensively on the product, on the why and how, and know how to answer all questions in our instead of us. And then those power users will be have presence in all business units or all across all the organization, and then they will be the convincing and explaining and show. This is power users is quite standard for us. In some cases, we do. For example, we are doing now the relaunch of L'Express, which is a French media paper. I'm training myself hundreds of journalists now, not now, but tomorrow, and this is kind of a second way to do it, but less efficient.
Maybe one thing also is when you introduce no code, you give the citizen developers, people from the business, to create a lot of applications. So it's not just change management, it's also governance, because that can create a very confusing portfolio of stuff that needs to be managed. So if you have your kind of governance of APIs, which is well managed, that's fine. But then you also need to kind of govern or organize the increased amount of applications that you're going to get from using no code.
Yeah.
My question to Antoine, is there already first to Mr. Pink, is there already
that's my new nickname, Mr. Pink. Okay.
Reservoir Dogs. Yeah. Is there already a shortage of no-code ops or no-code developers? And if yes, to Antoine, is artificial intelligence the answer to this shortage? And at what, how many years would it take?
So I don't have a crystal ball, so I wouldn't be able to answer the question. AI will definitely be part of coding and software engineering well, it is now. It is already now, but it's the role of AI in software engineering is going to go up dramatically in the years to come. That's for sure. I mean, there's no question about it, and we see that everywhere. Whether that will, I don't think it will it's not a question of replacement of no-code solutions. It's a question of, okay, how will we increase the productivity of developers so that we can maybe have fewer people doing the exact same thing. It's a bit like doctors. So I'm going to take an analogy with doctors. Take a radiologist. A radiologist, radiologists can be afraid that AI is now able to detect cancer cells better than themselves. So they might be afraid of disappearing altogether in the years to come. They won't disappear. What will disappear are what will may disappear or may go down are radiologists that do not use AI. So developers that do not use AI in the future will have a hard time probably.
And I think that the problem is that what changed. We used to talk about developers, like somebody who writes code, but actually now it's a more vague definition. So it's technologists. I don't like makers. It's technologists that use tools, AI, writing code, APIs, no-code tools, and maybe something else to create technology that solves real problem. And the world becomes more and more complex with more and more interaction. The software itself is exponentially more complex because solving more in a more fine-grained, in a more personalized way, everyday problems. So if we want to solve all the problems of the world in a very specific, personalized way, we will need a lot of technology. And let's say that change the name developers from developers to technologists, and that would be okay.
Yeah, and we add constraints every day: sustainability, efficiency, cost, privacy, etc., etc. So and security is probably the biggest. So we add constraints. So there's a risk for productivity and output of new features. So it needs to be compensated by new tools.
Questions? Yeah.
A quick question. Very clear explanation from different slides. I think that the assumption is that actually on the back office, everything is clean. Like you're coming and you have nice APIs, nice data, nice business logic that is coded. How do you assess at the start of your project? How do you assess if actually the no-code approach is going to be successful and not actually stumble on, oh, but this business logic is not correctly coded in your back office systems, or you don't have the right API to do that. So how do you assess that this is going to be actually a short approach and not actually going into, well, you need to go to your back office developers to change this because we can't do anything.
Right, that's the question. It's a very, very important question. Actually, this slide, the API is very small. In terms of efforts in a corporate, it's like 50%. If you take the whole thing, we are more like at 50% if you want to do things right. And that's the challenge. Just like you said, if you need to go back to your developers, etc., that's going to be a problem. Well, GraphQL, by the way, is an answer to this, because with GraphQL you can have you can spend less time to create APIs that are more fine-tuned to your exact needs, rather than trying to get one API for every single need or for every single use case.
Yeah, and I'll compliment that. First, thank you for talking about GraphQL, because one of the ways of solving that it's actually to if you have a lot of APIs to deal with, is to start to use GraphQL, because it will reduce tremendously the number of endpoints, the number of interaction between the front and the back. That's the first way. The second way, well, we talk a lot of APIs in the smaller, on the more smaller scale. There's still possibility to connect directly to the databases too, from the no-code tools. But yes, at the end of the journey, if you have a mess somewhere, you cannot cover the mess and make it disappear. So yes, you need to have some stable back-end business logic, but that actually the no-code could help with, because if you are building application by application, and for each you are building the front, the back, and sometimes you will need, I need another application to access that, and then you add some APIs to the app. that will result in a mess you're talking about. But when you, from the very beginning, you said that I'm in a headless world, when I have the front end usage on the one side, and I have my APIs, and you cannot communicate with anything in my, you cannot do anything in the business logic without going through APIs, will actually force the quality. And the reusability is another thing. Once you've been building one API for one application, will used only one, then the quality of that will be average. But when you're building an API on domain-driven design, organized in a microservices world, or microservices or microservices, then it's been used many times. Each time it's been used, the quality of this API starts to be a little bit better. Questions? No more? But I'm sure your backend is perfect. I know. So thank you very much, guys, and you replaced our your lunch with our presentation. That's very funny. Thank you very much, and have a good day.